So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life, as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Hypothetical planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it ExoVenus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 571501 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun. but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
We've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, The mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category, but this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
Perhaps we've all stopped to think at one point about what it would be like to live on another planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the stars in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they have found a new planet that might be able to support life. They call it TOI 700e. E! It's roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they call TOI 700d, but this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the conservative habitable zone. In simple terms, scientists aren't sure whether life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have some options. The two planets are in a solar system that's only 100 light-years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space and thrive for long periods of time. And history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technologies help us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it could take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, supersonic aircraft, but it's not the same. There's quite a difference, actually. Light is about 1 million times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that's not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go up to about 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret Option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh. Instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets in through the windows every day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life. But if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. So the next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, we don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low. But if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off of their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then, that would be a bad thing too. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, We use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics, or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window.
We'll start with one of the most recent and shocking discoveries of 2020. Perhaps our solar system has life beyond Earth. This is Venus, the second planet from the Sun and the sister of our home planet. It's called so because it has a similar size and mass, but the conditions on it are simply terrible. The temperature on its surface reaches 890 degrees Fahrenheit because of the greenhouse effect, and the atmospheric pressure on it is as strong as if you were 3,000 feet underwater. But in this hostile world, there can actually be life. For many years, there have been discussions on this subject. In 2007, scientists discovered there once had been an ocean on Venus. That is, in the distant past, there could have been some form of life. But in the fall of 2020, there was an epic argument in which scientists tried to find out whether life on Venus exists right now. In September, the discovery of a new life marker on Venus was announced. The ALMA telescope in the Atacama Desert found phosphine gas above the planet, and the amount of this gas suggested that it may have been produced by certain microorganisms. But already in October, the data was analyzed again, and the new results indicate it was an error. So today, we consider Venus to be uninhabited once more. But who knows? Maybe soon we'll get new data, and new disputes will arise in scientific circles. And while some scientists are scratching their heads and still concentrating on Venus, others have looked into distant space and discovered 24 planets on which life can exist. And on all of them, living conditions are much better than on Earth. Such planets are called superhabitable. These superplanets must be 1.3 times larger than the Earth and twice as massive. Thus, they will have stronger gravity and, as a consequence, a denser and warmer atmosphere. So, the climate on superhabitable planets must be similar to the tropical climate on Earth. This will ensure the maximum diversity of living organisms. The host star of such a planet must be a red dwarf. They're much smaller than the Sun and not so bright, but their lifespan can reach 70 billion years. For comparison, the lifespan of the Sun is 7 times shorter, and it's already past half of it. Slow and steady wins the race. It will give enough time for potential life to develop and evolve. And here's a suitable planet for the title of superhabitable, Kepler 1649c. In 2020, it was named the most similar planet to Earth. It's only 6% larger than our home world. It orbits a red dwarf, a quarter the size of our Sun. The planet is in the habitable zone of the star and makes a complete circle around it in 19.5 days. The climate on Kepler remains a mystery. It's known to receive about 75% of the light we get from the Sun. So the temperature on its surface may be close to Earth's, but we still don't know the composition of the atmosphere and other necessary conditions for life to appear there. The next discovery is one of the most amazing spectacles ever seen by humanity. It's the collision of a star with a black hole. In September 2019, scientists began watching how, for 6 months, a Sun-like star was being spaghettified. Light from this event traveled 215 million light-years, and we saw a star about 860,000 miles wide slurped up by a black hole. This black disk is so heavy that it has incredibly strong gravity. Nothing can leave its gravitational field. And now we see a star slowly approaching it. First, the glowing light layers of the star begin to stretch towards the black hole. It looks as if the star is simply unrolling like a ball of thread. Then we see this hot plasma lingering at the edges of the black hole. And it may seem these particles are now orbiting it, but it's just an illusion. This ring of light is called the event horizon. The black hole curves not only space, but time as well. This close to it, time slows down. To the observer, it looks as if the light near the edge of the black disk has almost stopped. But in fact, it has long been absorbed by the dark abyss. When a black hole eats a certain amount of star material, it starts spitting it out. Powerful beams of energy are ejected at speeds of over 6,000 miles per second. This is the light that attracted scientists' attention. In the end, the black hole has completely absorbed about half of the star and spit out the other half into space. And even though we watched this process for only a couple of minutes, it was happening for 6 months. And here is one of the youngest planetary systems that humanity has ever observed, AU Microscopii. It's so young, there's still a disk around it from the debris this system was made of. But this time, we don't even hope to find life here. The host star of this exoplanet continually emits radiation flares that would wipe out any form of life from the planet's surface. The planet that orbits this dangerous star is called AU Mc-B, and it's just a newborn baby by astronomical standards. It's so close to its star that it makes a complete circle around it in 8.5 days. The age of this planet is only 12 million years, so at the time AU Mc-B was born, mastodons walked on the surface of our planet, and meadows and savannas were covering the Earth's face. So you and I can consider ourselves old-timers, because the age of the Earth is almost 4.5 billion years. The next discovery took place in early 2020, and it's very similar to a landscape from science fiction. It's a planet with 2 suns. Well, more precisely, it doesn't orbit around a single star, as we are used to in our solar system, but around a binary star system, TOI 1338. The first big star is like the Sun. The other is a red dwarf, which is 3 times smaller. These stars completely circle each other in a little over 14 days. The planet that orbits these stars is the size of Saturn, which is much larger than the Earth. Although the sunsets and sunrises there look incredibly beautiful, this planet is unlikely to be suitable for any form of life. It's outside the habitable zone of its host stars, so it probably doesn't have liquid water. Mysterious radio signals from outer space have also been received in 2020. We're talking about fast radio bursts. Scientists recorded such signals before, but recently they have managed to prove that they are repeated after a certain period of time. The new data have forced the scientists to come up with a very bold theory that their source may be a magnetar. A magnetar is a neutron star that is small and has a huge mass compared to ordinary stars like the Sun. But they have the strongest magnetic field in the entire universe. Their lifetime is very short though, only 1 million years. But what baffled scientists the most this year was discovering that the moon is rusting. Corrosion needs oxygen and water to take place, but the moon doesn't have its own atmosphere to have both. The main theory says the solar wind is to blame. It moves at great speed and scrapes oxygen from the upper layers of the Earth's atmosphere. The wind continues to carry oxygen molecules through space, and eventually they reach the surface of the moon and cause metal ore to rust. By the way, the signature red color of Mars was created because of the rust. For a long time, there was an atmosphere and water. In combination with iron on its surface, it triggered a long process of rusting, which has lasted since ancient times. Another stunning discovery was found on the surface of the moon with a stratospheric telescope. It's an aircraft that carries a telescope. The plane raises it to an altitude of 8 miles, and this allows it to have a picture quality comparable to that of space telescopes. And with the help of such an unusual observatory, scientists were able to find water on the surface of the moon. Water molecules were found in one of the largest craters on the visible side of the satellite, but the number of water molecules is still extremely small there. The Sahara Desert has about 100 times more water than the surface of the moon.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect. But when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day. or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of two exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these two Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these two new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys Were Us, Wolfie and her mama will all be out there waiting for us.
Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be 2 different scenarios. The first is the destruction of both planets, and the second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the Sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. 2 massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years, and in the end, the two planets would transform into one giant world, and their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the Sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the Sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the Sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe. All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. we send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly and... is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis.
We've been focusing on trying to find life on Mars so much, while there is this gem waiting to be explored. This planet is the 6th farthest from the Sun and the 2nd largest in the solar system. You'll find it right behind Jupiter. I'm talking about Saturn, or as they sometimes call it, the jewel of the solar system. It's so different from our planet. First of all, you wouldn't be able to stand there. While Earth consists of rock and other tough stuff, this planet is like a giant ball, mostly made of gases. If you found a swimming pool huge enough to fit Saturn, you could see the planet floating in the water. No wonder, Saturn is the least dense planet in the solar system. It also contains a lot of helium. You know, the gas you put in balloons to make them hover in the air. Saturn is a very windy planet. Winds there are more than 4 times stronger than the ones we have on Earth. A day over there lasts 10 hours and 14 minutes because Saturn spins on its axis pretty fast. But the planet takes its time while going around the Sun. A year there equals 29 Earth years. Saturn's radius is more than 36,000 miles. It means the gas giant is 9 times wider than our planet. If Earth was the size of a nickel, Saturn would be as big as a volleyball. Even though some of our planets in our solar system also have rings, Saturn's are the most spectacular ones. You can even see its rings from Earth. And no, you don't have to be a scientist with insanely expensive equipment. All you need is a small telescope. Saturn's rings are not firm. They are made of pieces of dust, rock, and ice. Some of them are as small as grains of sand, and some as big as a house or even a mountain. These are actually bits of asteroids, comets, and shattered moons that fell apart before reaching Saturn. They could be torn into pieces by the planet's powerful gravitational pull. Saturn has over 50 moons, and recently, scientists have discovered some unusual hydrothermal activity on one of them. Enceladus is Saturn's sixth biggest moon. It has 4 tiger stripes close to one of its poles. Researchers have found that there is an ocean underneath these stripes. Water and ice erupt from that area, so now we can't but wonder, maybe there's life out there. In the oceans on Earth, some forms of life gather around similar hydrothermal vents. They feed on the chemicals there, same as plants on the surface do with sunlight. And not only that, some of the oldest microbial life on our planet feed on the same energy as the one produced beneath the ocean's surface on Enceladus. It could potentially mean there's life developing there right now. Of course, it takes millions and millions of years for even the simplest organisms to appear. But hopefully, scientists will need less time to find more complex forms of life. There are millions of exoplanets out there in space, and scientists have been searching for those that could be potentially habitable. Exoplanets are planets orbiting a star outside of our solar system. Dwarf stars are similar, less luminous than the Sun. They sometimes live for more than 10 billion years. That's enough time for a living organism to develop and evolve into a more complex form. Life might appear on the planets orbiting such dwarf stars, or, like with Saturn, on one of their moons. And here it is, Gliese 876b, that orbits the red dwarf star Gliese 876. This planet is mostly a mystery, but scientists assume this is a gas giant that has no solid surface. They believe its atmosphere doesn't have clouds, but there might be water in its liquid form on the planet's surface. T-Gardens b orbits a red dwarf that's around 12 light-years away from our solar system. The planet's mass is just a bit higher than that of Earth. Scientists think it may have a rocky surface. The planet needs around 5 days to complete its orbit. It means that 1 year on T-Gardens b is actually shorter than 1 week on Earth. Somewhere far, far away, there's another potentially habitable planet named Kepler 1638b. Okay, to be more precise, it's 3,000 light-years away from Earth in the constellation Cygnus. This planet is 4 times as heavy as Earth and twice as wide. It needs almost 260 days to complete 1 orbit around its star. The gravity on this planet is stronger than that on Earth. It wouldn't be an easy feat to jump on its surface. One more Kepler coming along. This time, it's Kepler 62e, a planet that's more than 1.5 times the size of Earth. Scientists believe this one has a warm, humid, and hospitable atmosphere with cloudy skies. There are 1,200 light-years between Earth and this planet. Kepler 62e needs 122 days to orbit its red dwarf star. Its neighbor, Kepler 62f, is another potentially habitable zone. It's a world around 40% bigger than Earth. Scientists think this planet might be covered in water. The oceans on our planet are full of interesting creatures and organisms of all sizes, so the chances are this planet also hides some intriguing living beings, or at least it has the potential to develop life. When we say habitable, it doesn't mean life definitely exists there. It just means there are conditions for some forms of life to develop. LHS 1140b is a planet located in one of the potentially habitable zones. Unlike its gas companions, it's solid and quite rocky. The planet's radius is 60% larger than that of Earth, and its mass is 7 times bigger. It's one of the densest planets found out there. Since the planet has a big mass, an atmosphere there must be rather thick. Plus, gravity on its surface is much stronger than here on Earth. That's why you would likely have problems just standing on that planet. Hello and greetings from TRAPPIST-1, an ultra-cool dwarf in the constellation Aquarius. It's around 39 light-years away from us. 7 Earth-sized rocky planets are orbiting in the star's habitable zone. All of them can potentially have some water on their surfaces. The temperature on these planets is more or less similar to that on Earth. On the Moon, gravity is only 16% of what we have on our home planet. That's why the astronauts could hardly control their movements when they visited our natural satellite. But when it comes to the gravity on TRAPPIST-1 planets, you would probably feel good and comfortable there. And Kepler, once again. This time it's Kepler 452b. It's a rocky planet 60% larger than Earth. Its parent star is similar to our Sun. This planet has actually spent around 6 billion years in the habitable zone. while Earth has been there for a mere 4.5 billion years. This planet needs 385 days to orbit Kepler 452. This star is around 20% brighter than our Sun, but has the same temperature. The whole system is very far from our little oasis. It would take you 28 million years to get there. And now, how about KOI 7711.01? It's another intriguing world 1,700 light-years away from us. This planet is only 30% bigger than Earth. It gets almost the same amount of heat as we receive from our Sun. Sometime in the future, people might start colonizing the galaxy. They would be looking for new planets to live on. Then we'd certainly have to make really long trips, and maybe one day we'd reach Proxima Centauri. It's a nearby star that has a couple of planets we could potentially inhabit, like Proxima Centauri b. It's around 4 light-years away from Earth, and it doesn't sound that far at first, but it actually is. It would take about 6,300 years to travel there, if we use the technologies that are available these days. It would mean many, many generations to make a trip like that, and it would take even longer to finally inhabit that new world. People would be born and raised on spaceships. They would live their lives there without ever seeing either Earth or the planet they're heading to. Instead of trees, mountains, and rivers, there would be only the dark nothingness of faraway galaxies spreading in front of them. They would never be able to wander unknown streets, breathe in the fresh air, feel the wind. The only place for them to travel to would be another part of the ship. Certainly, such a journey wouldn't be simple, but it would pay off if people managed to build some more beautiful worlds, like the one we have here on Earth. Is that even possible? Time will tell.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb Telescope use distinct approaches to find exoplanets. and the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot 4-inch-wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information. its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in. Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life, even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun, but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on superhabitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us. And with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. T-Garden b. It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. Teegarden B has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right, a year on Teegarden B is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super-Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140b. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere. And because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit. And it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there. So bring a big lunch. This is the closest exoplanet to us, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large. And to power it, we'll need the amount of energy close to what the whole planet of Jupiter generates. Still, Recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction, and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, in 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also two other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned. Hey there, Earthling! If you think you're special because you live on the only habitable planet out there, think again. What makes a planet suitable for life? A whole bunch of factors, like the planet itself, its neighbors, and the star it orbits. A habitable planet is basically one that can sustain life, with things like access to water, energy sources, and nutrients. Earth, for example, is in the sweet spot, known as the habitable zone, where it can have liquid water on its surface. But just being in this zone doesn't automatically mean a planet is habitable. Factors like crazy levels of radiation can make a planet uninhabitable, even if it has the right temperature. So the bottom line is, we need water, something to orbit, and a set of nutrients of chemical origin that can be found in Mendeleev's periodic table of the elements or those funky snacks you buy. Look at this exoplanet called K2-18b. The term exoplanet doesn't mean that it's exotic. It just states that this planet is located outside the solar system. Most planets need to orbit something, unless we're talking about rogue planets that are basically planet-sized things floating around in space but not orbiting around any star or brown dwarf. Instead of our Sun, K2-18b orbits a red dwarf called K2-18. It's not your average star you can see with the unaided eye in the night sky. This one is hard to observe because of its low luminosity. K2-18b is indeed a planet far, far away. It's located 38 parsecs away from Earth. 1 parsec is somewhere around 19 trillion miles. Hey, you do the math. Hint, lots of zeros. K2-18b is a sub-Neptune, meaning that it has a smaller radius than Neptune. However, it's much bigger than our humble abode. It's about 2.6 times the radius of Earth. As for the weight, K2-18b is way chunkier than Earth. It's about 8 times as massive. It takes 33 days for this planet to go around its star, and it gets just about as much starlight as Earth gets from the Sun. This planet has a light intensity of 1.28 times greater than Earth and has an equilibrium temperature of 28 degrees Fahrenheit. Nope, it doesn't mean that K2-18b feels like New York in January. It only gives us an idea of the theoretical temperature put there. The planetary equilibrium temperature is basically the temperature a planet would have if it was perfectly balanced in terms of radiation. It's when the amount of heat leaving a planet is the same as the amount of heat coming in. Now, the trillions of miles that set us apart aren't a problem for potent telescopes, such as the Kepler Space Telescope that discovered this planet and the James Webb Space Telescope that is studying its atmosphere now. In 2019, scientists announced that they had found water vapor in the atmosphere of exoplanet K2-18b, which sparked widespread interest toward this outlandish world. 4 years later, the Webb telescope detected carbon dioxide and methane swirling in the air of this guy. Carbon dioxide is basically our best friend here on Earth. Humans need it to breathe properly and keep our blood pH in check. And plants love this stuff too, because it helps them make oxygen through photosynthesis. Obviously, we can't survive without it, without methane either. However, this little gem got some scientists buzzing with excitement even more due to the discovery of some funky dimethyl sulfide gas molecules in its atmosphere. In 2023, scientists from the University of Cambridge spotted carbon-based molecules like methane and carbon dioxide hanging out on K2-18b with the help of JWST. This could mean that this exoplanet might feature a hydrogen-rich atmosphere and a watery surface. There's a potential whiff of dimethyl sulfide, or simply DMS, in the mix. On Earth, this stuff is usually linked to life, since it's normally produced by photoplankton in the oceans. The fact that we're picking up hints of DMS on K2-18b is like finding a golden ticket in the cosmic chocolate bar. Hey, kinda gives you the willies now, doesn't it? Why is DMS so important, you ask? Well, it's a bit of a superhero on our planet, playing a crucial role in the sulfur cycle and even affecting our climate by helping clouds form. And spotting DMS on other planets could be a sign of life similar to ours. Looks like this planet is a nice spot, with its not that rough temperature and all the right nutrients to keep us alive. So, what's your take on its overall look? It probably took the planet a good few million years to come together. While things might heat up deep down underground, it shouldn't make a big difference on the surface. Some experts believe it could be home to a water or molten lava ocean, with a hydrogen-rich atmosphere resembling a gas giant like Uranus or Neptune. Now this one doesn't really match our Earth standards, since our atmosphere is mostly made of nitrogen. If there's an ocean, it's likely under a thick layer of ice and rock, which could mess with the planet's climate. Once things get really hot, the line between the ocean and the sky blurs. We're not totally sure if there's a liquid ocean on K2-18b, and it's tricky to see one from afar. Just looking at the planet's size and weight won't give us the answer. The whole liquid water-ocean thing is up in the air. Initially, we thought water in a supercritical state was most likely, but new observations point toward a liquid ocean. Suspicious gases like hydrocarbons and ammonia might be moving from the air into the water if there's an ocean, which could mean no clear line between the sky and the sea. But some experts say a molten rock ocean could be doing the same trick. Others think a gas-rich mini-Neptune setup could explain things too. The Hubble Space Telescope did some snooping and found that K2-18b is rocking an atmosphere filled with hydrogen. They think there might be some water vapor hanging out there too, but it's a bit of a mystery. Apparently, the James Webb Space Telescope got a peek and saw less than 0.1% water vapor, possibly because the planet has a dry stratosphere vibe going on. As for ammonia, it's nearly non-existent in that distant world. Methane and carbon dioxide seem to be dominant in the atmosphere, making up about 1%. But don't expect to see any other carbon oxides crashing the party. Their concentration is just a guess at this point. The atmosphere of K2-18b is just a small fraction of its total mass, around 6.2%, and has probably got a similar vibe to Uranus and Neptune. Haze-wise, there's not much going on, and water clouds are a bit of a mystery. They're probably icy, although there's a chance for some liquid water clouds too. Now, besides water, the atmosphere could also contain some ammonium chloride, sodium sulfide, potassium chloride, and zinc sulfide clouds, depending on what the planet is into. And it seems like things might get a bit turned up high in the atmosphere, with the temperature inversion causing a stratosphere situation, just your average day in outer space. So far, scientists have come up with several climate models this planet might have. For example, some of them think that there's the same temperature across the whole planet, unless the planet is spinning super fast and the temperature difference between the poles and the equator is minor. But these are all speculations at this point. The amount of radiation K2-18b gets from his star is similar to what Earth gets. The temperature on the planet might be anywhere from really cold to pretty warm. Whether it can support life depends on its atmosphere and clouds. Scientists think microorganisms from Earth could survive there, even with all the hydrogen. But it's still hard to tell if there's life on K2-18b, because the gases we usually look for might not work in its atmosphere. Scientists think the James Webb Space Telescope might be able to detect different markers of life on the planet with enough observations.